Once you check out the source code to OpenLPR, you will find a number of folders in the source tree. I will go through each of these folders and describe their contents, but I believe it's important that I first describe the overall architecture of OpenLPR and talk about one key concept, which is the scalability and availability around which the whole system is built. Let me start with the overall architecture of the system. Broadly, the system is composed of 4 services: FTP, which receives images from sensors. This could be cameras, this could be snapshots from or keyframes from live video streams, or possibly any other stream that can extract frames and upload them via FTP to the FTP service. The second service is classification. So the job of the classification service is to classify what kind of plate it is. It's important to do so because once we classify what kind of plate it is, we can then intelligently perform OCR by ignoring areas or regions of the plate which do not apply to the current number plate. The third service is a detection service. So once a file is uploaded to FTP and an event is generated, the detection service tries to find a number plate in the image. It will find up to 10 number plates and it will report those. Finally, there is the OCR service. The OCR service tries to read the text out of the detected number plates based on the classification. In terms of sequence, first the images are uploaded to FTP service. The FTP service generates an event and publishes that to an exchange on RabbitMQ. This event is read by the detection service, which then uploads the result back to RabbitMQ through an exchange, which is received by the classification service, which does the same for each detected number plate. It tries to classify it, and finally it posts an update on RabbitMQ exchange, which is picked up by OCR, and then OCR goes through each of the detected number plates along with their classification and tries to perform text extraction. All of this is backed up by a shared file storage. Now this could be as simple as a folder on your server or your device, or it could be a volume which is mounted across different servers or computers. Likewise, all of the data which is generated by these services is updated in a MongoDB database. The database itself is very simple and it contains just one table which has records related to all the incoming and outgoing and processed data. We'll take a look into that in a few moments too. The other important concept is related to the availability and scalability of the system. So the general idea is that for the incoming workload, which could be up to dozens or hundreds of number plates or cars or images at a time, the task is distributed to multiple processing nodes. So you can consider all of these number plates shown here as the FTP service, which publishes information on a message exchange. The message exchange is bound to a queue, and a queue has readers associated with it. So you have something like a round robin algorithm, which is distributing the incoming request or images to different detection services. If we go back to the diagram, we may have up to hundreds of instances of this FTP service running at a given time, which could be clustered using public IPs so that different set of sensors reach out to different set of IP addresses, and the incoming load in terms of network is balanced across these servers. I'm talking about a very large scale deployment where you might want to do LPR on a whole city or on a highway or a very busy area. Similarly, each one of these servers may be running in a clustered mode. We'll talk more about that in another session, but we'll talk about deployment strategies. But just coming back here, because of this very plain and simple architecture, let's say if one of the services responsible for detection for some reason fails, we still have backups running at all times. So this will result in a delay in the service delivery, but it will not cause an outage. And since this system utilizes containers, specifically for now, I have released Docker images and a Docker Compose script to deploy the services. They are configured to be self-healing or supposed to restart in case of a failure. If you take a look at the Docker's documentation, there is an abundance of configuration that can be provided related to fault tolerance and recovery, which again we will talk about in some other session related to deployment strategies. But with this brief introduction to the architecture and design idea behind OpenLPR, let me start with describing the contents of each of the folders. So I will come back to the Docker folder in the end when we have some basic insight and understanding of what these services are. Once you check out the code, you may not see this env environment folder on your source tree, because this is a virtual environment I'm using to keep the dependencies for OpenLPR segregated from my other working environments. You can read more about how to use virtual environment if you're not already familiar with it.